So if someone is watching the recording, so I'll start teaching the session in about 2-3 minutes. So a few students can join. As of now, no one has joined yet. So yeah, I'll start teaching in 2-3 minutes. Okay. So hello, KS. So I guess you are the only one here. So I hope I'm audible and my video is visible. So just to reintroduce myself, like I'm Lakshya Saggi, the discrete maths TA for the Tuesday sessions. So this is, I think, our eighth session, and in this session, I'll be discussing problems related to, let's say, generating functions and yeah, mostly generating functions. So I guess I'll just get started with the problems. So yeah. So, so if there's any technical difficulty, like if you feel that like if you think if you're not able to hear me, or maybe if you're not able to hear me, then you'll not be able to hear this also. But like if you're having trouble with my mic or something, you can type in chat or let me know if there is some problem with my mic or my like screen or something. So hi Aditya. So I'm just going to start the session and I'll just share my screen. So yeah. So I'm starting I've shared my screen. So I hope my screen is visible to you guys. So if it is not visible, you can let me know via chat or yeah. So I'll just start with the problems right away. So this session, like Aditya, just to reiterate myself, since you just joined. So today we'll be discussing problems related to generating functions mostly. So yeah, let's just start with the first question. So first question says, what is the closed form expression of the generating function for the sequence this? So first of all, just to remind you guys about the definitions, what was you guys must have studied this in lectures, but just to remind you guys what is a generating function, what is a sequence. So sequence is nothing but uh, let's say uh, sequence is nothing but sequence is just a sequence of numbers. Or you can say like sequence is a mapping, a formal definition of a sequence is a mapping from natural numbers to real numbers. But you can just think of sequence as something like which like a series of numbers, which is in this form. Like first number can be thought of as A0, then the second number is A1, like third number is A2. Basically, you can think a series which is indexed. So like the first element of series is the zero index number, the second element is the one index number, third element is the second index numbers. So this forms the sequence. So like this is the sequence, like A0, A1, A2, A3, and up to like so on, up to infinity it can go on. So this is the sequence, and generating function of a sequence is equals to, let's say our sequence was this only. Let's say the sequence was this A0, A1, A2, A3 up to infinity. So its corresponding generating function would be A0 plus A1x plus A2x square. Okay, A2x square and so on till infinity. So nothing, just uh, so basically, generating function and sequence are rated as like A0 is the coefficient of x to the power 0, A1 is the coefficient of x to the power 1, A2 is the coefficient of x to the power 2, and so on. So this is the relation between a sequence and a generating function of a sequence. So another way to put it is let's say uh, if uh, if the generating sorry. So another way to put it is if the generating function for a sequence is f of x, then the uh, ith term of the sequence. So ith term, by ith term I mean a ith term. So like so this I can go from like 0 to infinity. So 0th term would be basically a0. So generating function of for a sequence is f of x, then the ith term is the coefficient of x to the power I in expansion of f of x. So, uh, so this is uh, and generating function is nothing but like generating function only shows the coefficient, like as the coefficients of x to the power I, it shows the ai term of the sequence. So we will put this as ai also. So I hope the relation between generating function and a sequence is clear, even though you have studied in lectures also. So yeah. So if we are done with the like this reminder, so now I guess we can proceed with the problems. So what is the question is asking what is the closed form expression of the generating function for the sequence 707070 and so on. So the sequence here is these sevens and zeros are alternating. So as I said that if a sequence is A0, A1, A2, A3 up to infinity, then its generating function can be given by A0 plus A1x plus A2x square and so on. So here the generating function, like in the expand, we need a closed form expression for the generating function. But first, let's write out the generating function in like actual in the expanded form. Like what is the expanded form of the generating function here? So what will be the expanded form? As we can see, A0 is given to us as 7, A1 is given to us as A1 is given to us as 0, and similarly A2 is given to us as 7. And this pattern sort of repeats, like 7070 pattern repeats. So this implies generating function. Let's say generating function is f of x. Okay, generating, let's say, uh, guys, maybe this been an issue. Size, yeah. Um, let's say the generating function is equals to f of x here. So what's the value of f of x in expanded form? That it can be written as, then f of x can be written as we already know, if the sequence is a0, a1, a2, a3 up to so on, then its generating function is nothing but a0 plus a1x plus a2x square and so on. So here a0 is 7, so f of x will be nothing but like 7 plus 0 times x, which will be like 0 only. So next we'll consider the coefficient of a2 times like a0 plus a1x, and a1 is 0, so a1x term will be 0. Then a2x square will be 7x square. And similarly, a3 is again 0 for our sequence. So a3 times x cube will also be 0. And then the term which will come is a4 times x to the 4. And a4 will again be 7 since this is an alternating sequence. So this function will have this sort of form. So it will be basically 7 plus 7x squared plus 7x to the power 4 plus 7x to the power 6, all the even powers of x, and so on. So this is the expanded form of our generating function. So for finding the closed form for this generating function, we already have studied this in high school, I believe, that this is nothing but just a GP, sum of GP, right? Like we can take 7 common out of this, and then it's nothing but 1 plus GP is geometric progression. So it's nothing but like 7 times 1 plus x squared plus x to the 4, and so on till infinity. Yeah. So this sums up to, you guys must have seen this in lectures also, and this is something which we have learned in high school as well. That this sort of like the sum of the series 1 plus x squared plus x cube up to so on is equals to 1 upon 1 minus x. And here we are taking instead as 1 plus x squared plus x to the power 4. We are not taking all the powers of x, but we are taking like the even powers of x. So this will sum up to 7 times 1 upon 1 minus x squared. So this is the denominator. So I hope you guys get the gist what I'm trying to write. Like this term sums up to this sort of thing, 1 upon 1 minus x squared. Since 1 plus y square up to infinity is equals to 1 upon 1 minus y, and we just put y as x square here. So we'll just get even part of x. So it will turn out to be like 1 upon 1 minus x squared. So this is nothing but 7 divided by 1 minus x squared. Yeah, this is our answer. This will be the, so this will be the closed form expression of our generating function. I'll just underline this answer. Yeah. I hope it was not too difficult. It's straightforward to see. So now let's come to the second question. So in the second question, it's asking what is the coefficient of x to the power 4 in expansion of 1 minus x raised to the power minus y. So uh, you guys must have seen in, like, let's say the lecture that coefficient. It's a straightforward problem out of like something taught in the lectures only. So I'll just write down the theory which is relevant to this answer. So you were searching that coefficient of x to the power r in the expansion of 1 minus x raised to the power minus n. So note that suppose this was only 1 minus x raised to the power 5 and not minus 5. Then what would be the coefficient of minus 4? It's very straightforward. Then it would just be like 5c4 types of thing, right? Uh, yeah, it would be 5c4, which will be equals to 5. But here we have 1 minus x raised to the power minus 5 and not 5. For 5, we can just do straightforward using binomial expansion. That 1 minus x raised to the power 5 will be nothing but like minus of x raised to the power 5 plus 5c4 times x raised to the power 4 minus 5c3 times x raised to the power 3 and so on. So x to the power 4 in that case will have coefficient of 5c4, which will be fine. But here we instead have 1 minus x raised to the power minus 5. So for this, the formula comes out to, you can calculate this yourself also, but if we have a straightforward formula, then we can just apply it also. So here the coefficient of x to the power x to the power r in the expansion of 1 minus x to the power minus n is given by n plus r. This is the r. N plus r minus 1. Choose r. Or maybe I'll just put it as CR. It's better. So this is the formula for like coefficient of x to the power for r in the expansion of 1 minus x raised to the power minus n. Like um, this is like straightforward attack from the lectures. It's nothing new. So we just need to put in the relevant values here. So note that this is the coefficient of x to the power r in the expansion of 1 minus x raised to the power minus n, not in n. Like here n is a positive number. Like if n were like, suppose we had to find in the expansion of 1 minus x raised to the power n, if n was positive, then it would just be like ncr, 1 minus 1 raised to the power r times ncr. But here we have 1 minus x raised to the power minus n. Okay. So here we'll put, here in this formula, we'll just put n equals to 5 as we need to find 1 minus x raised to the power minus 5. So here n will be actually 5. And you won't put n as minus 5, instead you will put n as 5 because here's a minus here already. This formula is for 1 minus x raised to the power minus n originally. So yeah. So to calculate this, we'll just need we'll just put r equals 4 since we need to find coefficient of x to the power 4 in the expansion of 1 minus x raised to the power minus 5. So we just put n equals 5 and r equals 4. Putting n equals 5, comma r equals 4 and r equals 4, we get, so I just copy paste this formula again. So n equals 5 will give me, this will be n equals 5, this will be r equals 4, 5 plus 4 minus 1, c4. And this will come out to nothing but like 5 plus 4 will be 9, 9 minus 1, 8. It will nothing but 8c4. 8c4. So this you can calculate what is 8c4, and this 8c4 will come out to 70. So yes, so this is the final answer here. So again, nothing too fancy, just a straightforward calculation and just application of the formula. So yeah. But yeah, one thing, like this is something I think you should remember, like what is the coefficient of 1 minus x raised to the power, like x to the power in x to the power r in expansion of 1 minus x raised to a minus n. You already remember via binomial theorem what is in 1 minus x raised to the power n, but sometimes it's beneficial to remember for the power minus n also. Otherwise, you can calculate it also. It's not a big deal, but I generally remember this formula. So yeah. So this comes out to 70. So I hope it's clear. Let's move on to next question then. So next question is asking, what is the sequence in the generating series for the expression 5x squared plus 10x cubed plus 15x to the power 4 plus 20x to the power 5 and so on. So note that, so here we have been given a generating function, which like where the coefficient of x squared is 5, x cubed is 10, x to the power 4 is 15, x to the power 5 is 20, and so on. So, and so on, by so on, I think it means like the next term will be like 25x to the power 6 plus 30x to the power 7. So essentially coefficients are increasing in by 5 every time for every power. So yeah, for x to the power 6, it will be 25, for x to the power 7, it will be 30, and so on. But note that coefficient of x, since there is no term of x raised to power 1 and x raised to power 0, because there is no linear term and there is no constant term. So coefficients of x to the power 0 and x to the power 1 are 0 here. That's why those terms are not present in this generating function. So I think you guys should always pay attention to this kind of stuff also, because that's why sometimes you can get stuck. So here for this generating function, as I had already discussed that if generating function is f of x, then ith term, which is ai, is the coefficient of x to the power I. So here was so here a0 will be, so in the sequence a0 is nothing but coefficient of x to the power 0 of x to the power 0. So which will be nothing but like here there is no constant term, so x to the power 0 is coefficient of 0, so it will be 0 only. And similarly, like a1 will also be 0 as there is no x to the power 1 term also. Similarly, a1 is 1. A1 is also 0. Then from generating function, we can see that a2 will be coefficient of x squared. So coefficient of x squared is 5. Then a2 is equals to 5. A3 equals 10. And a4 equals 15. Because like coefficient of x to the power 4 is 15. And so on. So our sequence is nothing but since our sequence is nothing but just like this sequence a0, a1, a2, a3, a4, and so on. So a0 is 0, a1 is 0. So our sequence is nothing but is it right? Then our sequence is 0, comma 0, since the sequence always starts from a0, so sequence will be nothing but a0, a1, which both will be 0. It will be 0, comma 0, comma, then a2 is 5, then a3 is 10, then a4 is 15. So now there will be like progression of 5, 10, 15, 20, and so on. So this is the sequence. I'll just underline this also. So note that even though the coefficients start from like, let's say 5, 10, 15, 20, but note that x to the power 0 and x to the power 1 have no coefficients here. So we need to consider their coefficients as 0 also. So some of you while attempting might make a silly mistake. You'll just see like coefficients are in the order like 5, 10, 15, 20. So you'll mark like option A as the correct answer. But we also need to consider the powers of x to the power 1 and coefficients of x to the power 1 and x to the power 0, which both are 0. So actually our sequence will start from 2 zeros and then it will be 5, and 15, 20, and so on. So the answer here will be like option D and not option A. So option D is the correct answer since it's 0, 0 constant x to the power 0 and x to the power 1 have 0 coefficient, then x to the power 2 has 5, x to the power 3 has 10, and so on. So yeah. So I'll just write it also. Hence, option D is what third question? Option D is the correct answer. Now let's come to fourth question. So if I'm moving too fast or there's something you're not able to understand, you guys can let me know via chat. So yeah. So now let's come to the fourth question. Oh, I just saw the chat and Aditya, you had written answer 70 for the second question. So yeah, you are correct. Like HC4 comes up to 70. So yeah, I missed your message earlier. Yeah, your answer was correct. So now let's come to the fourth question then. So fourth question is, what is the generating function of the sequence 0, 1, 2, 3, 4, and so on? So like this sequence, we can just see it will extend to like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like up to infinity. So again, like writing out the generating function for this sequence, it's nothing but like if the sequence is like, as I mentioned in the start, if sequence is A0, A1, A2, A3 up to so on, generating function is nothing but A0 plus A1x plus A2x squared and so on. So maybe I'll just write what is the closed form of the generating function. Like the expanded form of the generating function will be nothing but I'll just type it down. The generating function f of x will be nothing but, or maybe I'll just mention a little bit as a0 is equals to 0, a1 is equals to 1, a2 is equals to 2, and so on. So the generating function is nothing but like a0 plus a1x plus a2x squared and so on. So a0 will be 0. So like 0 plus 1 times x, which will be x, plus 2 times x squared, which will be like 2x squared, plus 3x cubed plus up to infinity. So case you are writing some answer to this question, and I think your answer is correct. It will be x upon 1 minus x to the power whole square. So I'll just explain the answer also, so others can also understand it. So I think your answer is correct, KS, but I'll still explain it for everyone. So the generating function is nothing but we can ignore the 0. It is nothing but x plus 2x squared plus 3x cubed and up to so on. So yeah, and here since x is common, what we can do is we can write it as f of x is equals to x times 1 plus 2x plus 3x squared, 3x squared plus 4x cubed plus 5x to the power 4. So up to like infinity. Yeah. So now our problem, so we have this x in common, we know this x. So now our problem reduces to finding the value of this, like what's the closed form expression for this sum, which is from 1 plus, which is 1 plus 2x, 3x squared plus 4x cubed up to 5x to the power 4 and so on. So there's a small trick to see this. I think you guys must have seen this in lectures also, but I'll just regardless explain it to you. So we know that so our main challenge is to calculate this sum. So till now, what we have found out is f of x can be written as x times this sum, and we need to find a closed form expression for this sum. So for finding closed form expression for this sum, you can see like it's something of a AGP, which we have seen, you guys must have seen in high school or something, but let's just ignore that for now. I'll just explain a better method. So we know from the lectures and like from straightforward maths, that 1 upon 1 minus x can be written is nothing but 1 plus x square plus x cube up to infinity, right? This formula I hope is known to everyone and is clear to everyone. Why is this so? It's nothing but like sum of an infinite GP, geometric progression. So yeah. So if I differentiate both sides with respect to x, differentiating both sides with respect to x, we get, I'll just move whole question to the next page. See it. Okay. Uh, So we know that 1 upon 1 minus x is this, and now differentiating both sides with respect to x, what will we get? We'll get basically what's the differentiation of 1 upon 1 minus x. I hope you guys know how to differentiate. It's not, we have learned this in high school, so it's a big deal. So it will just be like 1 minus x raised to the power minus 1. Its differentiation would be minus 1 times 1 minus x raised to the power minus 2 times minus 1. So it will be nothing but 1 upon 1 minus x raised to the power 2. So this will be the differentiation of 1 upon 1 minus x term. Like you can easily apply chain rule and differentiate it. And on the right hand side, what we'll get, the differentiation of 1 will be 0. The x will differentiate and will give us 1. X square will give us 2x. X cube will give 3x square. So this side will come out to nothing but 1 plus 2x plus 3x square. And similarly, like x to the power 4 will differentiate to 4x cube. So it will come out to 4x cube and up to infinity, like so on. So note that. So we have actually like we wanted this sort of sum. We wanted to calculate here only. Like for f of x, we wanted this sum only, like 1 plus 2x plus 3x square up to infinity. And we have like evaluated this to be equals to 1 upon 1 minus x whole square. So we are done. Like we can just put in the value for this. We can substitute this 1 upon 1 minus x square in our original expression. So I'll just write it down also. Substitute. Putting this value in expression of f of x, we get we'll be getting like f of x is equals to x times 1 plus 2x plus 3x square, which is nothing but 1 upon 1 minus x whole square. So 1 upon 1 minus x whole square. This will not say, we can just write it as like x upon 1 minus x whole square. So this will be the correct answer. I hope it's clear to everyone how we update this closed form expression. So if you did not have to obtain the closed form expression, the expanded form will be nothing but this only. So generally, when we write out generating functions, our target is generally to find like a closed form expression, because so that the generating function is more concise to write and we can perform more operations. Otherwise, like with this infinite sum, we can't do much if we want to proceed with this. So, like if we want to do some calculations on it or something like that. But yeah, so generally when we write generating function, we mean like writing the closed form of the generating function. Otherwise, it makes no sense or it does not provide any benefit. So yeah. So yeah, KS, you had written the answer as x 1 minus x whole square. So yeah, your answer was correct. So I hope it's clear. So let's move on to next question then. In the fifth question, it's asking in how many ways can 200 players be distributed among 10 teams so that each team gets at least 7 players and not more than 12. Okay. So what we want is we need to we have basically 200 players and we need to divide them into 10 teams. So every team also needs like at least 7 players, but every team should not consist of more than 12 players. So this is our goal here, that uh, we need to find such a team that we need to find such a division where we can be doing this. So how can you go about this? Maybe we can just try it out, think it along the way, how we can do this sort of stuff. So what we actually want to do is we need to divide 200 players, right? Amongst 10 teams. So what are the options? And each team should have at least 7 players, but not more than 12 players. So what are the options for the division? How each team can have either 7 players or 8 players or 9 players or 10 players or 11 or 12 players. Right? Since there are like number of players can be integer only, at least 7, not more than 12. So we need so I'll just write them also. Every team will consist of 7, 8, 9, 10, 11, or 12 players, right? Exactly this much. So, and there are 10 teams we know, right? And number of teams is equals to 10. Right? So what this means is that what we need to do is we need to find this distribution. Basically, we need to assign for every team one of these 5 numbers, like these 6 numbers. Like there are 10 teams. For every team, we need to assign one of these numbers. Like one team can get 7 players, other can get 8 players, other can get 10 players, someone else can get like 12 players, and so on. So this we need to divide in among uh, 200 players among 10 teams. So like what I'm saying is we need to divide, like either team should, all of the teams should get either 7 or 8 or 9 or 10 or 11 or 12 players. And the only constraint we have is that the sum of the number of players which each team is getting comes out to 200. Since we need to divide 200 players exactly, so what we need is we can just sign for every team. Like for one team we can sign 8 players, for other team we can sign 7 players and stuff like that. And what we just need to find out is what we need is that every the sum of the total players signed is 200. You can assume that the players are identical. So it's like that, like suppose team 1 gets 8 players and team 2 gets 7 players. So it doesn't matter which 7 players the team gets. Like as long as team 1 gets 8 players and team 2 gets 7 players, like that case is like counts as only one. It won't count as multiple cases that suppose player 1 goes to team 1 and player 1 goes to team 2. There won't be multiple cases. We just need to, you can treat players as identical here. Maybe I can write it down also. Players should be treated as identical objects. Since we just need to find the distribution of players, not exactly like which player is going to which team. We just need to find how many players are going to which team. And we need to find number of possible distributions of that. We don't need to find like if player 1 is going to team 1 or player 1 is going to team 2 and stuff like that. We just need to find if team 1 is getting 7 players or 8 players, 9 players, 10 players, and so on. So I hope it's clear to everyone. So now maybe I'll just write down another thing. So we need to assign each of the 10 teams some players such that each team gets 7 or 8 or or maybe as I said, greater than equals to 7 and less than equals to 12 players, and sum of players assigned over all teams is 200. So our problem can be rewritten in this way, that we need to assign 10 teams, like number of players such that like 7 to 12, and sum of players assigned over all teams should come out to 200. So now if we see the problem in this way, it's sort of easy to think that this can be formulated as, this can be thought of as, this can be thought of as finding the coefficient of x to the power 200. Maybe I'll just write this as coefficient only. Coefficient of x to the power 200 in the expansion of the expression x to the power 7 plus x to the power 8 plus x to the power 9 plus x to the power 10. Okay, I just copy this so I don't have to repeat it. X to the power 11 to the power 12 raised to the power 10. So how do I arrive at this expression? So what does this x to the power 7, x to the power 8, and up to x to the power 12 corresponds to? So this corresponds to nothing but the number of players which are assigned to one of the teams, right? So one team can either get 7 or 8 or 9 or 10 or 11 or 12. And since there are 10 teams, so we'll need to raise this to power 10, because uh, and we are like taking a product over these because the powers generally add up, right? So suppose if one team gets, like team one gets 9 players and team two gets, let's say, 10 players, then the coefficient, then the multiplication will be of this form: the x to the power 9 from the first term, and we'll multiply it with x to the power 10 of the second term. So similarly, now we have like 10 teams, so we'll multiply this over 10 terms, and we need to assign total 200 players. So we'll need to find the coefficient of x to the power 200 actually. So like, let's say the first 9 teams have been assigned only 7 players. So we'll just be like multiplying like x to the power 7 9 times for those teams. And for the last team, we'll be like multiplying whatever is the remaining number or something, even if it's possible. So in this way, we'll get like one type of sum 200, and similarly in another we will get 200, 200 in another form. So overall, like for x to the power 200, there will be multiple ways. And when all of the ways will add up, it will just be the coefficient of x to the power 200. So I hope I'm making a little bit of sense here, guys. So something along these lines has been discussed in the lectures also, right? So I think it should be clear to you guys. So I just gave the intuition like, why are these terms coming? So these x to the power 7, x to the power 8, x to the power 12 are coming because we have this constraint of greater than equal to 7 and less than equal to 12 players. And we have raising this to the power 10 because we have 10 teams. And then we are finding the quotient of x to the power 200 since we need total distribute like 200 players, since we are actually distributing these 200 players. So like, I hope this is clear to you guys. If it's not clear, you can ask in chat and maybe I can try to answer, because this is something like in which like I cannot explicitly state everything like why is it true, but it's more based on like intuition, and you guys should get the feel of it, like why is this actually true. So if it's not clear, maybe you can type in chat, otherwise uh, proceed. So like this is the answer. This can be thought of as x to the power 200 in expansion of this. So this is just option D. So option D is correct. So yeah, Aditya had written in chat option D. So yes, Aditya, your answer was correct. So, but I think you just guessed it, right? You since you have written like option D, you think it's correct. But your guess was correct. Yeah. So, just to point out again, this x to power 7 up to x to power 12 comes because of this 7 to 12 constraint. Then this power 10 comes because we have 10 teams. And then we are finding x to power 200's coefficient because we have 200 players. Maybe you can try to think about this after the lecture. And if you guys have doubts, you can ask us in the discussion forum also. So yeah, I'll just move on to next question for now, since no one is asking the chat since no one has any doubts in the chat. So yeah, let's come to sixth question then. So sixth question is saying how many 5-letter words can be formed from the following words, given that you have to pick one letter per line. Okay, so the question is basically asking us, so what we have been given is we have been given 3 lines. So one types of what we are given as RA, like R and A will come together. One is capital P and one is capital T. In another line, we have been given like 3 single alphabet words like E, Q, and S. So you're writing, so KS is writing the answer as 6. So yeah, KS, your answer is correct, but you calculated quite fast, I believe, for this question. But nonetheless, I'll just explain the answer for everyone. So just to, first of all, before explaining the answer, I'll just explain the question a little bit because I think this question can be a bit confusing. So the problem statement is saying nothing but uh, we have been given 3 lines, and in these 3 lines, we have been given like some words, like one word, like first line contains 3 words. First word contains like 2 alphabets, second word is of 1 alphabet, third word is of 1 alphabet. Similarly, second line contains 3 single alphabet words, and third line contains 2 words. One is of 1 alphabet, other is of 3 alphabets. So now what we need to do is we need to pick one word from each of these lines. So from first line, we might either need to pick RA or capital P or capital T. Some second line, we need to pick E, Q, or S. Third line, we pick G or like ION. And what we need is like we need to find 5-letter words which can be formed from the following words. So what we need to do is we need to like select from one word from the first line, one word from the second line, one word from the third line, such that they together make a 5-letter word, like exactly 5-letter word. Like it does not have to be an actual English word. Like let's say this word also suffices. Let's say like PEION, even though it's not a word, or let's say PQION. So PQION is not an English word, but for our sake, we'll just say it suffices. Like it's a 5-letter word. So what we need to do is we just need to count like in how many ways can we select this. So yeah. So this is the main question. So uh, okay, so Aditya has also explained the answer. So it will be nothing but coefficient of x to the power 5 in expansion of x squared plus 2x times 3x plus x cubed plus x. So yes, Aditya, your answer is correct. So so I think if you guys are answering this correctly, you guys start this in lecture. So nonetheless, I'll just explain it once. So what we need is a 5-letter word. So from first line, we need one of these 3 words. So it will either be RA or it will be B or it will be T. So it will be from first line. Like we get a factor of like RA is a 2-lettered word. So we can either take like X square from RA because like RA is a 2-letter word. So it will contribute 2 power 2. Similarly, P is a single letter word, so it can contribute only single power. And similarly, T is single letter word, so it can contribute again single power. From first second line, right, we get a factor of x plus x plus x, since all of these are single letter words. So similar. Third line, we get a factor of either we need to pick G or we need to pick ION. So G will contribute only 1, x to the power 1 since it's the one letter word, and ION will contribute x to the power 3 since it's a 3-letter word. So now maybe should I push this? I guess it's here. So I'm typing on next page now. So since we need to find a 5-letter words, since we need to form a 5-letter word. So, and the 5-letter word is of this kind that first word gets selected from the one of these three, second part selected from these three, and third part selected from these two. Since we need to form a 5-letter word, we need to find the coefficient of x to the power 5 in the expansion of like a product of these three terms. So in the expansion of x squared plus, this will come out to first term is just x squared plus 2x, second term is nothing but 3x, and third term is nothing but like x plus x cubed. So I hope this constraint is clear. Why do we get this as coefficient of x to the power 5 in these three products? Since at a time either of these two will contribute to these two will contribute to the word, one of these three will contribute like this three, one of these three will contribute to the word like one of these three will contribute to the word. So this will contribute a power of 2, this will contribute power of 1, this will contribute power of 1. All these three will contribute a single power of x, so they are 3x, and similarly here it will contribute single power of 1, and this will be like it will contribute a power of 3. So that's why this is x plus x cubed. So we take these products so that since if we multiply x to the power I and x to the power I, x to the power j, we get x to the power I plus j. So basically, for forming a 5-letter word, we'll just be multiplying these and taking the coefficient of x to the power 5. Since while multiplying these x to the x, like these powers of x, we'll just be adding actually the length of the words. So yeah. So for in the expansion of this, we need just to find the coefficient of x to the power 5. So you can calculate this, and this comes out to 6. This evaluates to 6. So yeah, 6 is the correct answer. So note that like this can be easily calculated. Like you need to find the coefficient of x to the power 5 in this. So this x can come out. So we'll just need to find the coefficient of x to the power 4 in like x squared plus 2x times 3 times x plus x cube, and it's easy to do. Like you can evaluate it. So this will come out to 6. So hence number of words of such words is equal to 6. This is the correct answer. So one takeaway from this I need to point out is that I'll just put it as a note also because I think it's very important. So how did we arrive at this solution? What we considered was we'll pick one of how we just asked how many 5-letter words can be formed from the following words. Given that you have to pick 1 letter per line. We just assume that we'll be picking 1 letter per line, but we have not assumed any permutations as such. We have calculated, maybe let's type it out. we have calculated the above answer, assuming that we are not doing any permutations of the words from different lines. So what I mean by this statement is, till now, like what you calculate the answer 6 by calculating the coefficient of x to the power 5 in the expansion of this. Till now, what we assumed is we are just picking RA, and we are just picking one of these three words. We are just picking one of these three words. We are picking one of these two words, right? So till now, what we have calculated, this answer 6 only comes out when we are just picking. But while forming a five-lettered word, we also need to sort of, like, suppose I pick RA and let's say, maybe I pick, let's say, PE and ION, right? So if I have picked, like, let's say these three words, like selected these three words like PE and ION to form an actual word, what I can do is maybe like one word can be PEION and another word could be like EPION, and similarly like IONEP. So basically, if I selected one word from each line, I can also permute it in 3 factorial ways, right? Since there are three words, one from each line, so I can also permute it in 3 factorial ways. So in that way, like, I'll actually be forming more five-lettered words, right? From like selecting one such triplet, like from these three lines, one from each of these lines. So from one triplet, I can actually get like 3 factorial words. From this PEION triplet, I can actually get, like, from rearranging it in 3 factorial ways, I'll get like 6 5-lettered words. So using that, like, actually, since we have 6 ways of picking these triplets, then I can also like permute each of these triplets in 3 factorial ways. So number of words which can actually be formed is like 6 times 6, which will be 36. But here for now in the question, we are just assuming that the word which we are forming is like, we are just picking one of these three, one word from each of these lines, and we are just like forming the word in this order only. Like, we'll put the first, we'll first put the word from the first line, then from second line, then from the third line. So I hope I'm making a little bit of sense, guys. What I'm saying, like, we are not considering any permutations amongst these lines. So if I pick P, E, and ION, I'll only be considering the word P, E, ION. I'll not be considering the words of the type like E, ION, and P. So this sort of thing, like, it can get a bit confusing, but here, like, it was just an assumption which was not too much clear in the question, but this was the assumption. So I'm just saying, like, don't focus on the what's the correct answer and what's not the correct answer, like why is the answer 6 and why is the answer not 36. Just focus, I'm just saying, just focus on the theory. So if someone has asked you to just find out the number of possible ways to select the triplets, then the correct answer is 6. But suppose there is also an option to like permute these triplets among themselves, then another factor of like 3 factorial will come, since these triplets can be permuted amongst themselves using 3 factorial ways also. Like, each of these 6 triplets can be permuted in 6 ways also. So the then answer will evaluate to 36. So I hope it's a bit more clear, like when do we have to when do we have to multiply an additional factor, and when do we not have to multiply. So if it's just a selection problem, then we are fine. But suppose it was like selection plus permutation problem, then you have to like multiply an additional factor here. So here, like, we have calculated the above answer as 6, assuming we are not doing any permutations of words from different lines. So if we were actually allowed to permute, then each of the selected triplet can be permuted in 3 factorial ways. So, like, let's say PEION. So it's a 5-letter word, and it's any permutation will also be a 5-letter word, right? So EPION will also be a 5-letter word. So in that way, like we are not also harming the 5-lettered condition. So if we were actually allowed to permute, then each of the triplet can be permuted in 3 factorial ways. So in that case, the total number of possible words formed will evaluate to, or maybe will be equal to number of possible triplets times 3 factorial, like 3 factorial nothing but 6. And number of possible triplets we have calculated as 6 here. So this will be like 6 times 6, which is 36. So this is something which you guys should keep in mind always, that when do, like if it's a selection plus permutation problem, uh, just giving us this like coefficient of this form won't give us the correct answer. We'll also need to like permute this stuff. So for permutation, you'll need to apply some further logic and you can get the answer afterwards. But here, like the question was designed, I guess it was not too much clear from the context, but it was designed assuming only the selection problem. So that's why you can see that like capital, like generally the first alphabet of the word is capitalized. So that's why the first line is capitalized. So just like sort of denoting that we are picking this word as first and this is second and this as third. So there's an inherent ordering. We can't permute in this amongst this ordering. So yeah. So is this clear, guys? Like KS and Aditya, like you both had told in chat the correct answer, that 6 is the correct answer. But do you understand like why was 6 the correct answer? Under what assumption is 6 the correct answer, and under what assumptions is 36 the correct answer? So is this distinction clear? Because like it can get a bit messy and confusing at times, but it's very important. Okay, so it's clear to you guys. Nice. So then maybe we can move on to the next question. So next question says, a bag contains several blue, green, purple, and yellow candies. Oh, a lot of candies. So in how many ways can Amit eat 8 candies from these blue, green, purple, and yellow colored candies? So again, quite a straightforward question, I would say. So the bag contains several of these like blue, green, purple, and yellow candies. So you don't need to worry about like the if these candies is restricted. So like you can pick 8 of blue candies also, 8 of green candies also, 8 of purple, 8 of yellow, or you can pick like 7 blue, 1 green, 7 blue, 1 purple, 7 blue, 1 yellow, and stuff like that. So you just need to eat 8 candies, and what are the different possible ways in which you can eat these candies? So maybe you guys, since you guys have like, I feel you guys already know a lot of stuff since you are able to answer previous questions. So maybe you guys can try to attempt its answer in the chat. It's not too hard, just a heads up. Or maybe I can try to like give a sort of a hint or like what's the correct direction for this question. So the answer to this will correspond to nice guys. So you are already writing the answer as 11C8. So yeah, your answer is correct. So yeah, the answer is 11C8. So and how is this the correct answer? Maybe we'll not do this by the coefficient approach if you guys just already know 11C8. So this can actually also be derived like this can also be written using the like the coefficient approach because like what you can say is maybe I'll just write now. The answer to this is the coefficient of x to the power 8 in the expansion of 1 plus x square plus x cubed up to so on raised to the power 4. So do you guys see this? Like, why would this be true? So the answer to this is basically the coefficient of x to the power 8 in the expansion of this. And why does this statement hold? This statement holds because since we have total 8, we need to eat total of 8 candies. And since there are like 4 types of colors, I'll just write down also. So since we need to eat, or let's say Amit, since Amit needs to eat 8 candies and there are 4 types of candies available, the answer to this is nothing but the coefficient of x to the power 8 in the expansion of 1 plus x plus x plus x cubed up to infinity to the power 4, raised to the power 4. Because there are 4 types of candies. So like, let's say from first color, let's say from blue color, only 2 candies are eaten. So a value of x square can be taken from the first, like from blue color, then from the green, let's say 4 candies are eaten. So x to the power 4 will come from green part. Then from purple, let's say only 0 candies are taken. So x to the power 0 will come from that part. And from yellow, the remaining part can come. And similarly for all other possible combinations also. So, and the total should come out, the total power should come out to 8. So in all the possible ways, when we sum up all the, like when we sum up all the possible ways of x to the power 8, we'll just get the coefficient of x to the power 8. Right. So is this clear to you guys? How is this written as this? Like it's in the same vein as when we did this question, like dividing 200 by 100 teams. In fact, I think this was a more difficult question than this question. So just taking this into account. So yeah, so this is nothing but something which we have already done. This is nothing but 1 upon 1 minus x. 1 upon 1 minus x. Like this is just 1 plus x square equals to 1 upon 1 minus x, as we have already seen. So this raised to power 4 will be 1 raised to power 4 upon 1 minus x raised to power 4. 1 raised to power 4 is nothing but 1, and 1 minus x raised to power 4. So this is like 1 minus x raised to the power minus 4. So as we already did, so we just need to find coefficient of x to the power 8 in the expansion of 1 minus x raised to power minus 4. So I'll just copy paste the formula again. Where was the formula for? Yeah. So just copy this statement again. Yeah. So others, maybe it's obvious, but I still think that I should copy this so that others, everyone can easily see why is this true. Putting R is 4 and N is 4 and R is 8, I'll get nothing but like 4 plus 8 minus 1 C 8, which is nothing but 11 C8. So this will evaluate to 11 times 10 times 9 divided by, I'm not calculated its value, but it will come out. Let me just calculate it orally. 11 times 10 times 9 divided by 6. It will be 110 times 3 by 2. So it will be 55 times 3. So it will be 165. So this will be the correct answer. So 165. So I hope it's clear to you guys, like why did we get this as that answer? So if it's clear, I'll just move on to next question. You guys have already answered this as 11C8, which was the correct answer. There's another way to see this, but I guess using like balls and sticks sort of stuff. If you guys don't know about that, maybe you can just ignore it, but these sort of like distribution arguments can also be done using balls and sticks kind of stuff. So like we need to eat, let's say 8 candies, and I can maybe like divide, like I can assign like what types of uh, candies do I need to eat. And so I put like this, suppose there are 8 balls and I need to put 3 sort of sticks between these balls so that I can divide the region into like 4 regions, blue, green, purple, and yellow regions. So there's some method based on that. Maybe you can Google it if you don't know about it, or if you know about it, then it's very well. From that also, you can just straightforward see the answer would be 11CA using balls and sticks method, or otherwise using this like expansion, using this coefficient of x to the power 8 in expansion of this also. We just straightforward it. So it's generally like, I generally prefer to think like, if you think in more than one ways for the same question, I believe it's good for you, because in that way you build your intuition more, like you build your counting intuition more, like how there are many ways to count the same thing. So you discover new methods if you try to count by different ways. So it's always good to think of stuff in more than one ways. So yeah. Okay, sorry. So now let's come to eighth question. So eighth question is asking, find the closed form expression of the generating function for the sequence 111, 121, 133, 114, and so on. So it's easy to see what's this sequence. This is nothing but 11 to the power 0, 11 to the power 1, 11 to the power 2, 11 cube, 11 to the power 4, 11 to the power 5, and so on. So this will not be, let me go think. A0. Right. It's easy to see that in the sequence, AI is equals to 11 to the power, right? So the generating function, hence the generating function f of x is nothing but 1 plus 11x plus 11 square x square, or maybe I'll just write it as 11x whole square. 11x whole square. Since it's nothing but 11 square x square, so I can put 11x together and then I'll get 11x whole square. Similarly, next term will be 11 cube x cube, which will be nothing but 11x whole cube. And similarly, 11x raised to power 4. And so on. Right. So yeah, KS, your answer is correct. So KS has already answered this in chat, but I will still write it down. So generating function, the no expanded form generating function is nothing but f of x is 1 plus 11x plus 11x whole square plus 11x whole cube plus 11x whole raised to power 4 and so on. So basically we need to find a closed form for this expression. So generally, guys, like last time also in one of the previous questions also, like we need to find a closed form expression, closed form for an expression which we already didn't know. So we started with like this 1 upon 1 minus x and differentiated it, and we obtained this expression, right? So generally, a good way to start to find out the value of an infinite expression is to start from this basic expression. And maybe you can like modify this expression in some sort of sense. So to obtain the expression which you actually want to calculate, the closed form for the expression which you actually want to calculate. So maybe I'll just use this expression again in our option, and you will see why I'm doing this. So this is nothing but like, let's say if we assume like 11x to be something like a y, like let's say 11x is a variable which is y. So this generating function in terms of y will be nothing but like let's say I'll just put 11x equals y, or maybe yeah, put 11x equals y. Then this generating function in terms of y can be written as like this can be also written as f of y. Then f of y is equals to uh, f of x will be equals to nothing but f of uh, okay, yeah. Maybe let's just ignore this. So I'll just write that in the above expression, put 11x equals to y. Then what we get is f of x can be written as nothing but 1 plus y square plus y cube and so on. So what I was mentioning earlier also, like this is nothing but just we already know from lectures and stuff that this will be nothing but 1 upon 1 minus y, right? That's what I was saying. Like maybe we can like this is a very basic formula which we already know, and starting from this, like using this formula, we are generally able to compute like using this sort of expression. We were earlier able to compute 1 plus 2y plus 3y square plus 4y cube just by differentiating this. And here, if we put like y as 11x here, then we'll be able to compute this series. So then, since if we put y as 11x, what we'll obtain on this side will be nothing but 1 plus 11x plus 11x whole square plus 11x whole cube, which is the expression which we want. And this will be equals to 1 upon 1 minus 11x. So, so this is this. So just so f of x is nothing but 1 upon 1 minus y, which is equals to 1 upon, like since y was actually 11x, so it is nothing but 1 upon 1 minus 11x. So I just like what I was mentioning was that this formula is very useful. Like this identity can be manipulated in more than one ways, sometimes by putting some value for y, or sometimes by differentiating or integrating and stuff like that to obtain like different forms of different closed form expressions for like infinite sums. So just keep in mind that this is a very important expression always. So we get f of x is 1 upon 1 minus y, putting back the value y is 11x, we get this as 1 upon 1 minus 11x. So yeah, this is the correct answer. So KS, you had written in chat the answer is 1 upon 1 minus 11x. So yeah, your answer was correct. Good job. So, I guess let's come to the ninth question then. So ninth question is just straightforward true or false question. So it's asking 1 plus x raised to power 6 is the generating function for the sequence 6c0, 6c1, 6c2. So this parenthesis and like in this parenthesis, when you write like this number at the top and bottom, it just denotes like the C operation, like combination operation. So like this is nothing but 6c0, this is 6 choose 1, this is 6 choose 2, up to 6 choose 6. So yeah. So I think it's an easy question, guys. So 1 plus x raised to power 6 is the generating function for the sequence this. Is this statement true or false? Aditya or Case, any of you can answer in chat. I think this is pretty easy. Is this typing? So yeah, it's true. I don't think it's too difficult to see. So true. As 1 plus x raised to the power 6 as a coefficient of 6 choose r of x to the power r. So for x to the power r has a coefficient of x, choose r for r from 0 to 6 and a coefficient of 0 for higher power of x. So it's just straightforward binomial theorem. So which has studied in high school. So 6, this just evaluates to 1 plus x to the power 6 evaluates to 6c0 x to the power 0 plus 6c1 x to the power 1 plus 6c2 x to the power 2 and up to 6c6 x to the power 6 until that it terminates. So x to the power 7, x to the power 8, and 8, x to the power 9, everything has a coefficient of 0. So yeah. But note that if it was like instead 1 plus x raised to the power minus 6, then this statement would have been like obviously false. So then there would be no zeros, there would be like an infinite sequence of combinations. So bear that in mind that 1 plus x raised to the power some positive number. Here this sequence terminates, like what I'm going to terminate that after some time there will always be zeros. But if it was like, let's say 1 plus x raised to minus n, in that case, it won't terminate. There won't be a sequence of zeros. There will be like more combinations generated. So yeah, nothing too fancy. It's just straight. Wait a second, guys. Sorry, there was someone calling me. So I hope like 9th question is clear. So now let's come to 10th question. Then like, the last question for the day. I'll just move this to a new page. And so 10th question is not too difficult like that. So what the 10th question is asking is like, what is the sequence generated by the function 1 plus x or 1 minus x whole cube? So maybe you guys can try to like attempt this question. So would you guys like to give it a go? Like it's not as straightforward, but it's not too difficult either. Like what we just need to find is what is the sequence. So generally sequence, like you can just say like you can just list out the expansion and you can just list out some of the terms, but we just need to sort of characterize like what will be the AI term. Like if I want to like a sequence is like item of sequence is characterized in terms of I. So I just want to I just want you guys to answer like what will be the AI term in terms of I. Like it can be something like 2 to the power I cube, y square, something like that. So okay. So KS is written in chat that this corresponds to like the sequence is coming out to 1, 4, 9, 16, 25, 36, and so on. So how would you characterize this? Like what will be the value of AI? If you are like what I generally prefer is when you are writing when you generally want to write a sequence, you should characterize it in terms of I. So okay, so maybe I'll just answer this. So here the sequence will come out to, maybe I'll just write the answer first and explanation later. The sequence of A will be like 1, 4, 9, 16, 25, and so on. So what this means is that so AI is nothing but, so like A0 is 1. A1 is 4, A2 is 9. So it is just like, you can just see that this is the progression of squares shifted by 1. So AI will be given by I plus 1 to the whole square. This will be the correct answer. So, and how do you obtain this? I don't think it's, yeah. So yeah, yes, you're correct. So we can basically split this, the numerator in two parts and then try to find out the different sums. So yeah, actually, I'm impressed by you, okay, that you are able to do calculations so fast. Like while I was reading the question, you were able to obtain the answer in that time. Good job. So yeah, so just pointing it out for others. So let's copy this. F of x is given to us as this. So we can just sort of write it as a, to insert the equation. Yeah, I will do it. So this can be like written as 1 upon 1 minus x to the cube plus, I'm just separating out the numerator into two parts, like this will be 1 upon 1 minus x to the cube plus x upon 1 minus x to cube. So now I can sort of like find what's the item of this sequence and what's the item of this sequence, and I can sum up. So basically just seeing that what will be this. So 1 upon 1 minus x cube, maybe I can just find out its expansion, like what will be its expansion. So what will the expansion for the first part, this 1 upon 1 minus x cube part? So it will be 1 plus 3x plus, or maybe okay, so should I just write it down for you guys? I guess I can write out. So it will be like 1 plus 3x plus, I believe this will come out to 3 times 3 minus 1 by 2. So it will come out to like 6x squared and so on for the first term. And just reduce this font size. Okay, you can't reduce it. Plus this, basically, so what I'm just doing is like, I'm maybe I got you guys a bit confused. Sorry for that. So what I'm just trying to say is that uh, I just listed out this 1 upon 1 minus x cube as this, like this is nothing but like 1 plus 3x plus 6x squared plus, like you can write the future terms also. And then this x times, like this 1 up x upon 1 minus x cube can be written as just x times this number, right? So I'll just copy this and it will be nothing but x times this. That's why I wanted a different line for this. So I guess I'll have to just write the bullet and copy and paste it in the next line. So I'll just insert an equation. Insert equation. So I hope it's a lot better with Keynote. So this will then evaluate to. So we just need to find, so like I just opened this up. So 1 upon 1 minus x cube will not be nothing but 1 plus 3x plus 6x squared plus so on, plus x times 1 upon 1 minus x cube. So it will be x times 1 plus 3x plus 6x squared plus so on. So now we need to find the sum of these two terms to find the actual value of fx. So the constant term will only be 1 since here it's a factor of x. And like the second term, the coefficient of x to the power 1 will be like, it will contribute a factor of 3 from here. And from here, it will be like x times 1. So 1, so factor of 1 will be from here. And similarly, for coefficient of x square, we'll be having a factor of 6 from here. And here I'll be having like 3x square, like 3x multiplied by x. So it will contribute a factor of 9x square. So like this is 4x and 9x square. And like you will be able to observe that next term, you can also complete, like you can see this for yourself, that next term will come out to like 16x cube. And why will this come out to 16x cube? Maybe you guys can write out yourself and you can find it. Like what will be the coefficient, the next coefficient of x cube, and like it will come out to something like 10x cube, I believe. And from that, and after the 10x cube, from here 6x square will be added, like 6x square times x. So it will, so we'll add 6x cube more. So we'll obtain like 16x cube, and like so on. This will be the final generating function. So maybe it can be underlined also. But no, maybe I'll try to underline. Okay. Let's just leave it at that. So yeah. So we obtain the value of f of x as 1 plus 4x plus 9x squared plus 16x cubed. So what we then can say is that, so the series is, the sequence is nothing but coefficient of x to the power 0 is 1, coefficient of x to the power 1 is 4, coefficient of x to the power 4 is 9. So sequence is nothing but like 1, 4, 9, 16, 25. So yeah, this was the correct answer which I mentioned at the start. So I just underlined. So I hope it's a bit clear to you guys, like how I arrived at this expression. So I think I just like, we just split the numerator into two parts and evaluate these two parts independently. Like we know the formulas for these two parts. We know like how to expand 1 upon 1 minus x cube. And here we just need to multiply, like we just needed to expand 1 upon 1 minus x cube and multiply by x. And then we just needed to add, and we saw this pattern that we are obtaining that 1 plus 4x plus 9x squared plus 16x cubed up to so on. So we obtain this sequence. So I hope this is clear to you guys. So KS had already written this solution in the chat. So good job, KS. So anyways, Aditya, is this clear to you also? How we arrived at this expression? I don't think there's too much of a conceptual thing here. It's just a calculation based question, but I still think it's a good question since it tests the basics of generating functions. Okay, so it's clear to you, right? So nice. So I guess like this was all which I had prepared for today. So this was the last question which I had prepared for today. So like from my side, like I have discussed all the problems for now. So if you guys, like, since we have like around like 20 minutes more, so either we can stop the session early, or if you guys have any doubts, maybe I can take those doubts also. So if any of you has any doubts, maybe you can ask your doubt in chat, or if you don't have any doubt, maybe you can leave the session, and I'll also like close the session afterwards, like close the meeting afterwards. So do you guys have any doubts like for today or like from some previous sessions? If you guys have any doubt, like you can ask me. Okay, so I guess since none of you is typing in the chat right now, so I believe you will. I'll assume that you guys don't have any doubts for now. So maybe I'll close. I'll just, okay, KS is typing something. Okay. Because you're typing. Okay. So I guess you both of you don't have any doubts. So I guess we'll close the session for now. So today's session is over for now. So I hope you enjoyed today's session. So next we'll be meeting again next Tuesday, same timing, 6 to 8. So I hope to see you guys there. So yeah, thanks for attending the session, guys. We'll see you next week, hopefully. So I'll just stop the screen and stop the recording, and you guys can leave the meeting if you want. Thanks for attending, guys. Goodbye.